Okay, so let's talk internal positive force notation for a beam. When we have been talking about reactions and I find a reaction, then I might say that AY is 60 pounds up. So we use a magnitude, we use a unit, and when we use direction. Okay. When we start looking at internal forces, how are these external forces that we have on our system transferred? Okay. When we start looking internal, we are going to use positive beam notation. Okay. So if I have my beam and it's loaded and I want to cut it and I want to see what's happening right inside, okay, because these forces have to transfer their loads to the reaction so we can just keep transferring down through our system. So if I cut my beam and I can look at my beam from the left, okay, or I can look at my beam from the right. When I look internal, I have three possibilities. Actually, there's going to be four. I'll touch on that in a minute. In statics, we looked at normal, shear, and bending moment. We looked at normal, shear, and bending moment. It's important to understand that with internal forces, internal moments, we're actually talking about behavior, and which is why you can't just choose a direction. If I'm coming from left to right for my solution set, and I assume that my normal is in tension, and I get a value that's positive that tells me it's in tension, and I draw an arrow to the right, well, how do I know that you're not drawing that arrow to the right on this right side? Because that would indicate pushing it compression. Okay, so that's why we talk behavior. So with normal force, okay, it's going to pull it. If we have a positive normal force, then we call that tension. If we have a negative, we call that compression. And we've already looked at these when we looked at trusses. Those are two force members. Two force members only have tension or compression. So if I have a beam and I have an X load on it and I'm pulling it, okay, so when I cut that beam, look at the inside, I'm going to assume tension. If I indeed get that I'm in tension, I get a positive value, I'm going to call that like 20 kips, and it's positive. If I were to have compression, and let me find this. So if I have compression and I'm pushing internally, so now I'm pushing this way towards the left, we can see on this side for compression, we're pushing towards the right. So again, that's why you cannot have a direction. That's going to be compression. So if I said it was negative 20 kips, then you and I both know negative means it's a compression member. It's like a column. It's being pushed, as opposed to a cable, which might be in tension. Trusses are going to have both tension and compression. When I look at internal shear, positive shear gives me clockwise rotation. So if I push this down, okay, if I push this down, then we are rigid body, and we can see that it's rotating down, and we would have an angle that we can calculate, which we'll be doing that in strengths. Again, if I have this member and okay, those are both clockwise rotations. So that's what the positive shear is going to give us. Okay, so positive shear gives clockwise rotation, which is opposite of right-hand rule. Okay, if I look at a moment, okay, if I'm coming from this end and twist up, then this is going to have a tendency to want to smile up. If I'm looking at my right side and I twist up, again, it's going to have that tendency to smile. So when we have a positive moment, then our curvature is going to look something like this, and we know we have compression member or compression fibers top and tension bottom. If I have negative moment, so if this were going down, then I can see with negative moment, my curvature is going to be a rainbow or an unhappy face. And I'm just copying here, a rainbow, an unhappy face, whatever you want to call it. So again, if I have this right here, and let's look at this. this right here, and I want to look at the rotation. If I have positive curvature, it's going to curve up like I don't know which way to go, a rainbow. Negative curvature, it's going to curve down like curvature up is smiley face, curvature down is rainbow. Okay, you guys get it. So we always have to use positive because we are talking about behavior. We have to assume that all three of these are there in a beam, even if we don't have any like tensile or compressive forces, because I would just need to indicate that my normal force equals 0. If my loading changes, it could then change the value that I have. The other thing is that actually in strengths, we don't just have normal, and we don't just have shear, and we don't just have bending moment, but we could also have torsion. And we don't talk about torsion a lot in statics, but it's actually the force, the fourth internal force that we need to look at. The other thing we don't talk about in statics is the fact that, let's see if I can get this drawn, is we look at bending kind of one directional. Okay, we look at bending about this axis, and we could have positive moment. We could also have bending about, and we could have shear across, okay, perpendicular. So when we start looking at things like three-dimensionally, keep in mind statics is pretty simplified with just this, but real world, when I look at this cross section, if I could draw this cross section again, we'll try to do that quickly, okay? I could have a normal force or compressive, tensile or compressive. I could have twisting, so like I am wringing out a wash rag. I could have shear in this direction. I could have shear in this direction. I could have bending moment in this direction, and I could have bending moment in that direction. So just keep that in mind, that we will be moving from basically this very simplistic idea to looking at all 6 internal force moments that we could be finding.